So let's go ahead and do the check for example 4, and then we'll go to example 5. So the check, very important before you start any sort of factoring problem, it has to be equal to 0. In this case, it's already set equal to 0, so you can start off. I think one of the examples later in this section has one where it doesn't. It's not equal to 0, and we'll get to that. So this is just a basic trinomial. So what I'm going to do is I'm going to factor it. So two numbers that multiply to 24, they can add a 10. Remember, you can make a list, okay, if you don't know these numbers very well. I do, so I'm going to go ahead and just start it off. So 6 and 4 minus will get me the numbers that I need. So that's just plain old factoring. To solve, we split them and set them both equal to 0. Okay, add 6, add 4. So I get x equals 6, x equals 4, and those are my two answers. Remember, if I wanted to put these on a graph, they would appear on the x-axis. Those are your roots. Okay, example 5. There's two ways you can do example 5. In the way that they do it, you have a difference of squares. We have a minus, we have two pieces, they're both square rootable, so I can go ahead, square root the 49 to get 7 and 7, which they have there, square root the x squared, which makes x and x, so that's there, okay? We set them both equal to 0, and then we solve. So minus 7, and then you could add x here and move it to the other side. Minus 7. So one answer is negative 7. The other answer is positive 7. And there you go. Okay. If you wanted to check your answer, you could plug it back in and make sure it equals 0. That's what they're saying here at the bottom. So if something doesn't look right, plug it back into your original equation if you want to know.